the surface energy balance, and this is the in section 1.31 in the textbook. Imagine we have a large plane surface here, and with the heat conduct inside, and have it also exchange heat with the outer environment, can be convection or radiation. Let's assume. And the total surface is at the temperature of Ts. How can we deal with the heat transfer? The heat exchange with the outer environment for this plane surface. For problems, we know what's the typical steps we should answer questions. First step.
Energy balance.
But before energy balance, there should be one more. Define your control volume. Then that's where we apply our energy balance or energy rate balance. If we don't define your control volume first, then there is no point where we should apply. So if I pick a very thin layer, exactly on the surface, on the surface interface, and establish our energy rate balance, which is Q in minus Q out plus Q generation equals the energy stored inside the control volume. And it should hold for any control volume I picked on this surface. If I pick a very, very thin control volume, what can be the term for volumetric generation? Right, if for a volume, if I just wrote here for a volume, is almost 0 or tends to 0. Volumetric term is exactly 0. For any assumption you make, briefly state why the reason why we pick this assumption. And how about the heat stored? Also 0, because for 0 volume, there is nowhere to store the heat, either gained or lost. Then we have our energy rate balance. Simply, Q in equal to Q out. What is Q in? The conduction from through the medium. But on the surface, that's where we define our control volume. It's not the conduction here, or not the conduction there, but exactly the conduction on the surface. And the Q out, the heat exchange with the environment, can be convection, can be radiation, can be contact resistance, can be some other complex mechanisms. But with this very simple equation here, we can connect those complex surface conditions with the conduction flux inside the body. And applying Fourier's law is simply equal to minus the thermal conductivity times temperature gradient, but on the surface. That's the energy rate balance on the surface.